proof of induction involving questions which involve inequalities. And there's no real difference from what we've done before, except in step 1 we need to take care. Step 1 is, as we know by now, is show true for n equal to, and it's always the smallest value of n. Always the smallest value of n. And you can very easily miss this because it says here s belongs to natural numbers. So in your heads you're thinking, oh yes, it's 1, 2, 3, 4, 5, dot, 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 going on forever, and you choose the value of n equals 1 without thinking. But you must go back and read the question carefully. And it does say here there's a restriction on the n. And it does say that n is greater than or equal to 2. And because it says n is greater than or equal to 2, then that implies that n equals 2 is the smallest number that you are going to be employing in order to work this problem out. So back to step 1. Oh, by the way, all of this is probably just done in your head. You know, you're reading the question, you're making a judgment call, you write it down. So, I've just written it there for illustration purposes, and feel free to do that moving forward. But you would probably just read the question, look at the highlighted n is greater than or equal to 2, and then choose n equals 2. So for step 1, this time, we're breaking the mold slightly, we're showing true for n equals 2. So, showing true for n equals 2, the left-hand side is 4 to the power of n. Therefore, it's 4 to the power of 2, and therefore it's equal to 16. So the left-hand side is equal to 16. The right-hand side is equal to 4n plus 1. So it's going to be 4 on 2 plus 1, which is going to be 4 2s are 8, plus 1 is 9. So the right-hand side is equal to 9. Clearly, the left-hand side is greater than the right-hand side, and therefore we have shown true for n equals 2, and step 1 is finished. So now we go on to step 2. And step 2, you should all know by now, is assume true for n equals k. So therefore, what are we assuming is true? Well, it was 4 to the n, so n is now equal to k, so it's 4 to the k, is greater than 4 on k plus 1 is assumed true. Okay, so that's now done, and I'm hiving off that area there. So now we're on to step 3. And step 3 is need to show true for n equals k plus 1 using step 2 brackets and possibly step 1. Okay, so now we need to demonstrate what we're trying to show is true. Therefore, need to show that 4 to the power of k plus 1, because the n is now becoming k plus 1, is greater than 4 empty bracket, because we're replacing the n with a k plus 1 plus 1, is true. And of course, in your head, you're saying using step 2. I do think we can do a bit of tidying up. So we need to show, therefore, we need to show, we're not going to write that again, 4k plus 4 plus 1. We need to show that 4 to the power of k plus 1 is greater than 4k plus 5. So we need to show that the left-hand side is greater than 4k plus 5 using step 2. So let's get the ball rolling. So we start off with the left-hand side, and the left-hand side is 4 to the power of k plus 1. And you're guaranteed method marks for this because you should know by now there's only one thing you can do with this. And that is, we've got a power 4 to the k plus 1. And the only thing we can do is use the laws of indices on it. And we've got addition law. We've got powers added together. So the only thing we can do on this is use the addition law. And the addition of powers leads to the multiplication of bases. So we've got 4 to the 1 multiplied by 4 to the k. So there's a chance, an outside chance, that you've got a method mark for that line. But have you used step 2 yet? The answer is no, you haven't. So to be absolutely guaranteed that you are going to get method marks, you need to use step 2. Now, step 2 is different from normal because you're not just replacing the 4 to the power of k, you're also replacing the equal sign. Because over here, you've got a greater than symbol. So when you're using step 2, this is when you're putting in the greater than symbol, because that's what it says there. The 4 is not the step 2. The step 2 is 4k plus 1. So there's my empty bracket, 4k plus 1. Close my empty bracket, because what I've done is I've replaced the 4 to the power of k with a greater than symbol and this. So I replaced my 4 to the power of k with a greater than symbol and what's inside, because that's what step 2 is telling me to do. And that is the problem area that some students have. It's failing to spot that they have to substitute for the greater than symbol as well. Because you're so used to just substituting in the algebraic expression, you forget that the symbol has changed as well. Okay, so we're down to that. Now, mathematically, the next line is equal to the line above, so I'm using an equal sign. 4 on 4k is 16k plus 4. Now, I don't know if you've spotted this. We have a bit of a problem, because the right-hand side, which I forgot to write earlier, because we do need a focal point, so we know what we're aiming for. So I'll put it in red now. I need the right-hand side to look like 4 times k plus 5. Now, this isn't rocket science, because what I can do now is, well, just write it in. Hang on a minute. Well, that's not right. It's meant to be 16 plus 16. I've written plus 4. I need an adjustment. What's the adjustment? Oh, 12k. Well, that's not difficult. And then, what do I need on the right-hand side? According to this red box, I need the 4k. Got the 4k. I need the plus 5. So, put a plus 5 in. What's wrong with that? Put a plus 5 in. Oh, hang on a minute. I haven't got plus 5 on the previous line. I've got 4. So what have I got to do? I've got to adjust it. So what am I adjusting it to? Well, I have to put an adjustment of -1 in. Ooh. So now, please forgive me for saying this, we cheat. I know mathematically that 4 to the k plus 5 plus 12k minus 1 is definitely bigger than 4k plus 5 if and only if, we haven't heard that expression in a while, if and only if the 12k minus 1 is bigger than, well, what's it got to be? If 4k plus, if 4k plus 5, if this line here is bigger than 4k plus 5, then the value of this thing here, come on, pause the video, think about it. Yes, you're right. It has to be bigger than 0. It can't be negative. Now, some of you are going to get that, and some of you aren't. Some of you are going to remember to do this in the exam, and some of you aren't. And the problem is, why are you sweating it? Because your very next line, if you're stuck here, is leave it and go on to step 4, proof follows by induction, gather your method marks, move on. Sorry to other maths teachers watching the video, I know that's offended you now, but hey, we'll go back to the problem and solve it. So, I need to show that this thing here is greater than 0. So let's see if it is. If 12k minus 1 is greater than 0, if 12k minus 1 is greater than 0, then 12k must be greater than 1, mustn't it? And if 12k is greater than 1, then k must be greater than 1 over 12. But go all the way back to step 1. What is the smallest value of n? Well, according to step 1, the smallest value of n is 2. So k has to be bigger than 2, doesn't it? Has to be bigger than or equal to 2 from step 1. Therefore, it's definitely bigger than 1 over 12. So, at long last, hooray, fireworks! From step 1, k is greater than or equal to 2. Therefore, step 4, proof, no room, follows by induction. Ta-da! Finished. Okay then. Let's move on to the next example. Factorials. So, I've made this really clear here. This is the example, it's question 7 of exercise 11.4. So basically, I've given you one of the questions as an example. Step 1, let's just go for it, shall we? Step 1, show true for n equal to, let's read the question, n is greater than or equal to 4 and belongs to the set of natural numbers. Therefore, the smallest value of n that we are showing true for is n equals 4. So, left-hand side, what is the left-hand side? Well, the left-hand side is n factorial. So, it's 4 factorial. What is 4 factorial? Well, it's 4 times 3 times 2 times 1. Now, I make that 24. I do hope I'm right. Right-hand side. The right-hand side is 2 to the power of n. So what we got now? We've got 2 to the power of 4. And 2 to the power of 4 is 2 times 2 times 2 times 2. And that is 16. So therefore, the left-hand side is 24. The right-hand side is 16. and therefore quite clearly the left-hand side is greater than the right-hand side, therefore shown true. Okay, first bit done. Step 2. Assume true for n equals k. Therefore, k factorial is assumed to be greater than 2 to the power of k. Okay, that's the end of step 2. So now we're looking at step 3. Need to show true for n equals k plus 1 using step 2 and possibly step 1. Therefore, I need to show, now use the empty bracket method, I'm replacing the n, I'm highlighting now, I'm replacing the n, open bracket, with k plus 1. So it's k plus 1 factorial. And I need to show that that is greater than, replacing the n in the original formula by k plus 1, greater than 2 to the power of k plus 1. Is true. Obviously using step 2. So now we're going to do the proof. I think I forgot to write that word in last time. So proof, left-hand side is equal to k plus 1 factorial. Might need to do a bit of revision there. So we need to make the left-hand side look like step 2. Let's remind ourselves what factorial is. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And you should spot that this thing here is in actual fact 5 factorial. So therefore 6 factorial can be written as 6 on 5 factorial. So the rule with factorials is wherever you stop, you can actually write a factorial. So I could have gone 6 times 5 times, and the rest of it is 4 factorial. Now you might want to pause, you might want to write that down on a separate sheet of paper and think about it for a few minutes. Because now I'm going to do it for k plus 1 factorial. So what do I know about k plus 1 factorial? Well, I know it's going to be k plus 1, and then you drop down 1, so you to k, and then you drop down 1, k minus 1, and then you drop down 1, k minus 2, dot, 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 all the way down to 1. But what does this mean here? Well, this is simply k factorial. So therefore, k plus 1 factorial is k plus 1 on k factorial. So, you might want to ponder that. I just did it up there as sort of a little reminder of what we did when we were doing factorials. Now I'm going to rub all that out because that's not going to necessarily feature in an exam situation, but feel free to do it if it helps you focus. So we just do it down here. So what is the left-hand side? Well, the left-hand side, I'm going to break down the factorial. So I write down the first, k plus 1 times k, but instead of continuing it, I just put the factorial symbol there. What was the whole point of that? Well, k factorial is, in actual fact, step 2. And step 2 means you're going to replace the k factorial by a greater than 2 to the power of k. So this is when the equal sign becomes a greater than, and you've got k plus 1 on 2 to the power of k. Can't believe I did it again. I forgot to write down the right-hand side. Well, the right-hand side is 2 to the power of k plus 1. Now, in this particular proof by induction, it's actually probably easier at this stage to work off the right-hand side. So the right-hand side is the additions of powers, and the addition of powers reduces to the multiplication of bases, where that's going to be to the power of 1, and that's going to be to the power of k. Now, you need to be supremely confident in your mathematics, because you need to say, well, I know that the left-hand side is bigger than the right-hand side. So I know, my heart of hearts, I know that this is bigger than 2 to the k, which is equal to 2 to the k plus 1. I know this is bigger, but it's only going to be bigger if the k plus 1 is bigger than the 2, isn't it? For this to be bigger than that, those two are equal, so therefore the k plus 1. So this from here to here is only true if and only if k plus 1 is bigger than 2. This is only true if and only if k is bigger than 1. How do I know it is? Well, pause the video, go back, read the question. What's it say in step 1? The smallest value of n is 4. So therefore the smallest value of k has to be 4. So is k definitely bigger than 1? It surely is. So from step 1, k is bigger than 4. Therefore, step 4, proof follows by induction. Write that statement in. Proof follows by induction, and you'll get your full marks. But for God's sake, remember to write in proof follows by induction.